Okay, we're gonna be talking about something called the chain rule. You're like, the chain rule, what the heck? What's the chain rule? All the chain rule's talking about is how we would take a derivative if we have a composite function. You're like, okay, composite, what is that even talking about? A composite function just means that there's a function within another function. So it's a function in a function. That's what makes something composite. F of g of x. G of x is in f, okay? So, which of these would you say represents a composite function? We're just brainstorming here, you guys. There ain't no shame. Which one is a function within a function, might we say? Any guesses? You're saying G. And why did I not tab here? I'm very sad at myself. I don't know. G is totally a function within a function. So you guys, let's just circle it. And anyone have any ideas which one would be the outer versus the inner function? Again, we're brainstorming. No one's seen this before.
X squared is inner.
Yeah, the x squared is on the inside and the sign is on the outside. Very good. I think it's just going to be helpful to write that as we start seeing these. Why do you think I got an M&M if I'm talking about an outer and an inner? Yeah, what's on the outside?
Just a shell.
It's a little hard candy shell, which is delicious if you ask me. What's another one that has an outer and an inner by chance? Top right. This one is, and this one's a little funky. This one is going to be my outer, my 3, and then my exponent's going to be my inner, which is a little funky. And you might be like, but that's kind of on the outside. I hear you. I'll explain as I've got that x in the exponent why that one's my outer. There's one more. So bottom right is 3x, 3 times x times e to the x.
I believe it's f of x, no?
This one again is x times the sine of x.
What makes it a function in a function versus being multiplied?
Yeah. Let me show you. It is this one. What would be my outer function? The thing to the 4th power. Exactly. This is my outer function right there. Good, you guys. We're just brainstorming. This x plus 5x is the inner.
Is it if it has an exponent or something? What makes it outer versus inner?
Let's, like this guy here, why isn't this a function within a function? Can we just take the derivative of this guy?
Yeah.
3x squared. So that is just one function. Can we take the derivative of that guy? Yeah. So we haven't had anything this complex yet, if you will, okay? Over here, we can do product rule to multiply 3x times e to the x is not as complex, meaning the derivative of this inner thing is no longer 1. Up until today, the derivative of, say, this exponent was always 1. The derivative, if I gave you, hey, the derivative of sine of x, what's the derivative of that? Cosine of x, because if we thought about x as my inner, which it technically is, what's the derivative of that inner? 1, and it wouldn't affect anything. So up until today, my inner function always had a derivative of 1, and now my inner function's not going to have a derivative of 1. We're going to start applying this chain rule. So, again, I brought M&Ms because, again, we have some outer and inner function, a shell and some chocolate, if you will, right? So before I pass them out, let's just real fast. We agree, we saw this above, that this was the outer and this was the inner. What about this one over here? How can I rewrite that as an exponent?
1/3.
Yeah, wait, isn't this the same as h of x to the, it always goes power over root?
Yep.
So it'd be to the
Wait.
1/3 would just be the original. This is the cube root of something is the same as something to the 1/3, and we don't have to worry about taking that derivative yet. Here's what I want us to see, and then we're going to get some chocolate on our hands. You guys, if something's given to us like this, which one of these is the outer and the inner? F is the outer. You guys go ahead and put that. Boom. F is the outer. What's G? That's the inner. How do I apply this chain rule? What are they telling us to do? Take the derivative of the outer. Eat the shell of your M&M. Then what do you do with the chocolate when you're eating the shell? You leave it. That's perfect. We are going to have to work on today how to eat an M&M, just the shell. Leave that chocolate. Then what do we multiply by? The derivative of that inner, the derivative of the chocolate. Let's try it. Okay, so as you enjoy your M&M, one shell at a time. You eat the outer shell. That's the derivative of the outer. You leave the chocolate as you eat the shell. Then you multiply it by the derivative of the chocolate. You're finally going to enjoy that chocolate, okay? So now I want to tell you why we love, actually no, let's practice it, then I'm going to tell you why we're grateful for the chain rule. Right here, we've seen this problem 3 times. This is the outer, this is the inner. How would I take the derivative of the shell first? How would I eat the shell? What's the derivative of something to the 4th power? 4 blank to the third. That's the derivative of the outer, right? That right there is my F prime. What am I supposed to do with my G, which is that chocolate?
Leave it.
I just leave it. What stays in there? X cubed plus 5x. What then do we have to multiply by? When you're eating your M&M, you do want to enjoy the chocolate at some point. Derivative of that inner. She says 3x squared plus
5.
done.
Let's go.
Do you need to take it any further? Absolutely not. What a gift, right? Prior to the chain rule, you want to know how we'd have to take this derivative?
Something miserable.
Let's think back in algebra. I'd have to take x cubed plus 5x to the 4th by hand. Then, after all of that, we've done no calculus. I'd have to go take the derivative of everything by itself. Would it be equivalent to this? Yeah. Is this so much easier? Thank goodness for the chain rule is all I'm saying. Okay? Let's go over here. Let's go over here. Graham Nellis, how am I going to say this again? This is the same as h of x to the, you know it. That's just my algebra skills. You guys, we got to eat the shell first. What's the derivative of my outer? Where's that 1/3 go? 1/3 blank to the. 1/3 minus 1 would be 1/3 minus 3/3. Is negative 2/3. What did I do with that inner, that chocolate when I ate the shell? You leave it. Then what do I do with that chocolate?
Prime it, yo.
I prime it. I eat it by saying multiply that by h prime. Deal? This is the chain rule, people. I like the chain rule because we get M&Ms. Whew. Okay, E is a little difficult. Okay, I really wish I didn't start with this one because this one's hard in my opinion. But we can do it. You guys, we still love E. I still love E. What's the derivative of E to anything? You know it. But the chain rule says we still got to take the derivative of that exponent.
3.
Yeah. That's my answer now. Why did I never have to worry about that before? Because it was always an x. The derivative of x was 1. So let me say this one more time. Whoops. This is E. Yep, real fast. This guy was my outer.
Yeah.
This guy was my inner. The derivative of e to the anything is still, we still love e to the anything, times, we left my x, we left my g, right? My inner, and then we got to multiply by the derivative of that inner.
So it would be e times 3x.
E to the 3x times 3.
Okay.
Yep.
I see.
And then I just threw that
I just thought
3
we
out
could
front.
bring-
This is hard. Which one do you think is my outer? Yeah, this is my outer. You guys, let's go back to just, what if I just said ln of x? What's y prime? It's 1 over x because that's here.
Wouldn't it just be 1 then?
Careful, times the derivative of that.
1 over 1.
Okay, so this guy, now we're going over here, I feel like. The derivative natural log is 1 over this every time. Because, bless you,
Bless you.
this was my inner, and we don't get to touch the inner, right? You just ate the shell, and we did that. Do we need to multiply by the derivative of the inner?
5.
Yeah, which is 5. Could I say my final answer is 5 over 5x plus 1?
Yes.
Yeah, don't have to. Do you agree, bless you? We've only been taking one derivative at a time. We did 1 over this. And then you're going to multiply by another derivative. That's how that chain rule is working. We can't do it all in one step, okay? One derivative at a time, one layer of your M&M at a time. Okay, let's try this guy. We love E. Derivative E, leave it. E to the side of x minus 3x. We leave it. But we do need to multiply that by what? The derivative of G. Cosine of x minus 3. If I left out parentheses and I went like this, is that equivalent? No. Problem. We got a problem. Here we go. Ooh. Ooh. 1 over the thing in the parentheses every time times the derivative of the things in the parentheses. So close, Bodie. So close. Sine over cosine gets me tangent. It is cotangent. Oh, you don't have to apologize. He says sorry. Okay, we're going to skip 5 for Thursday. Let's go to 6.
Secant.
Which one's my outer? This one's my outer. Let's go in a prettier pink here. This is my inner. The derivative of secant is secant tangent. What am I going to do with that 2x if that's my inner? It becomes secant of, careful, we can only do one derivative at a time. So okay, let me back this up. If my function was secant of x, and I said the derivative is secant x tangent x. Agreed. He's saying, wait, I got to leave my outer, derivative of my outer, which is secant tangent, leave the inner. The angle stays. Yes, this right here is the derivative of the outer. You left the inner. We still need to multiply this by the derivative of the inner. 2. Could I put that 2 here?
Yes.
Could I put it here?
Yes.
Could I make it this?
No.
No, can't mess with the angle, okay, guys? But you could make it, I'm going to make it a coefficient. Okay, here we go, people. We're going to be good at this. H is cosine of f of x. You guys, what I want to clarify, do you agree this is not cosine times f of x?
Correct.
It's not, because if it was, it would have to be cosine of x times f of x. You always need an angle with your trig function. So this is, which one's my outer, you guys? Yeah, this one's my outer. What's my inner?
F of x.
Yes. You guys, let's just take this with respect to x first. Negative sign that you just ate the shell. What do you do with the chocolate when you ate the shell? You leave it. Times the derivative of the inner. Yes. Where do they want that derivative?
1.
Okay, then we have a nice little chart. And you guys, I really tried my darndest to retype everything from AP Classroom, but I didn't type some charts. Sorry. We're going to need h prime of 1, negative sign. What's f of 1? I. Times f prime of 1. 4 root 3. If this was free response, we'd be done there. They're not going to give you this as free response. They're going to give it to you as multiple choice. So we got to think about this unit circle. Pi over 6. The first one. What's the sign there? 1 half. Negate it. Negative 1 half times 4 root 3. Final answer. Negative 2 root 3. Awesome. Good job, you guys. How about if I said J? We love E. We love E. We love E. So J prime of X is going to be E to the, yes, you can only do one derivative at a time. That's one derivative. Thank you, Soph. She says, the derivative of E is E to the times the derivative of the to the. We got G at prime. Now we want J prime of 2. We get E to the G of 2 times G prime of 2. And I get these steps are excessive and they're annoying to write out. But you guys, this calculus is so advanced, I really think it's important to write it out each time or else we're going to make a mistake. E to the G of 2. What's G of 2? 8 times g prime of 2. Could I write my final answer as 5e to the 8th?
Yes, you can.
Okay, you guys, what's going to be my outer and my inner of this p of x?
J.
J is my outer, is my inner. So let's go find p prime of x first. Eat that shell. J prime, leave the chocolate, times the derivative of the chocolate. Love it. We need this in terms of 1. They're saying H is this line, and I'll highlight that, and then J is this line. We need H of 1.
3.
You agree H of 1 is 3, so I got J prime of 3, and then we need H prime of 1. H prime, when x is 1, is my slope here. What are we rising and running? Awesome, Care Bear. -3. What about J prime of 3? 3 is here. Oh, right here, girlfriend, check this out. When x it was 1 of my H graph, the slope here was down 3 over 1.
Oh, the slope.
Yep, because it was H prime of 1 that we needed there.
Yeah.
J prime of 3. So of my pink graph, x is 3 here. The slope this entire time is down 1 over 3. Love it. J prime of 3 is -1/3. Times -3 is 1. Does anyone get a little salty that we just did all that work and the answer is 1?
Yes.
Okay, guys, I want you to get a little confidence booster. Go try this guy on your own. AP test question. I want you to try these 2.
Well, there's no low. It's just.
Yeah, this is just a good old chain rule, right? Don't we have an outer and an inner?
Yep.
E
Cosine times 3x plus 1.
cosine of 3x plus 1 times 3. That's it. Here's what I want you guys to do. Our homework is just the front page of the homework packet. Those 4 questions at the front page of the homework packet.